Hello, I'm Michael Bender, and welcome to our first micro lesson on project requirements. Well, what are requirements? Well, quite simply, they're the features, functions, and characteristics of the deliverables that we'll be giving the client. So for example, let's say I ask you to build me a table. What kinds of questions would you ask? Well, you'd probably want to know the size, shape, perhaps the material to use. You'd want to know how much weight it would take. Let's take a look at what requirements really entail.
So, what are requirements? Well, quite simply, they are the characteristics, features, and functions of the project and its deliverables. In project management, we break them into two kinds. The first kind are the product requirements. These define the characteristics, features, and functions of the deliverables themselves. They're required by the customer so that they'll accept the deliverables. Therefore, they're also known as exit criteria. These also define the quality metrics that we'll use to prove to the customer that we've given them what they've asked for. The second kind are project requirements. These define the characteristics, features, and functions of the project itself. They're required by both the customer and the performing organization. They usually include schedule and cost requirements, but may also include other standards such as safety and security. They may also include constraints. Here are some examples of product requirements. We'll continue with our example of our table. Notice we have the size and shape of the table, as well as how much weight it will support. We've specified what we want the table made of, as well as how it's finished. Certainly we would need other requirements as well, maybe the size and shape of the legs, or any other characteristics and features that we would want for our table. And here are some project requirements for our table. Notice that we have schedule requirements, not just for the completion of the table, but we also may have milestone completion schedule requirements. We also have included safety standards regarding the construction of our table, as well as some budgetary requirements.
So, what are the characteristics of good requirements? Well, you already may be familiar with Peter Drucker's SMART model. S stands for specific. You noticed we specified mahogany for our table, not just wood. M, measurable. This not only eases design, it also allows us to prove our requirements to our customer, ensuring that we're giving them exactly what they want. A, agreed to. Not just by the client, but by my team and my quality assurance group. R is realistic. Basically means we can do it, based on our cost, schedule, and resource constraints that may be put on our project. And finally, T, time-bound. Certainly our project needs to have some deadlines. The measurable characteristic is frequently more difficult than it appears. Remember, requirements define the quality metrics for customer acceptance. In my projects, I had to prove I met every requirement to get paid. I once faced a particularly difficult example. The requirement read, there shall be no more than a 13 millisecond delay between the time the character is struck on the keyboard till the time the character is echoed on the screen. While seemingly silly in the 21st century, it was the late 1990s, and the system we were integrating with was archaic even then. And this requirement was actually legitimate. The requirement contains measurements. However, we couldn't figure out how to test it. There are three formal ways of proving requirements. 1, testing. You can run a test that proves the requirement. 2, inspection. Here, the customer simply sees that you've met the requirement. This is useful for aesthetic or other obvious requirements. And 3, analysis. You can do analysis of the system to prove the requirement. In our system, neither of these were practical. I told the client, the only way we can test this is to hire an electrical engineer, dismantle a keyboard, buy a high-speed camera to view the screen, electronically tag the frame where this key was struck, determine a % phosphor glow to determine when the character was echoed, and count frames. Including this test would add another 4 weeks and $80,000 to the project, and I get to keep the high-speed camera. Of course, the client didn't want that. We eventually agreed on a high-speed typing example that could be clocked with a stopwatch. The client was quite happy with that, although I was sad I didn't get to keep the high-speed camera. So we added a fourth method for accepting requirements. If you can't test it, if you can't inspect it, and if you can't analyze it, at least agree on a test. I won't accept requirement until my QA department has figured out how to test it. That is a hard and fast rule that I never violate. Get your QA people on board while you're developing your requirements. From my personal experience, it's a lifesaver. Now, let's take a look at a couple do's and don'ts regarding requirements. First, I don't know if you noticed, but when I was showing you examples of good requirements a few slides ago, I always use the verb shall. Every time I use the verb shall, that defines a requirement, and I never use the verb otherwise. I learned this trick doing government work, and I find it works extremely well in industry. Now, let's also take a look at a couple things to avoid when you're doing requirements.
Here are some things to avoid while writing requirements. First, I see a lot of project managers including operational statements in their requirements. The first statement, the system shall provide a database backup function, is in fact a requirement. It describes a feature of the system, while the second statement, the database will be backed up nightly, is an operational statement. It describes how a user or operator will use the system. Notice that I delineate the statements by changing the verb. The requirement uses the verb shall, while the operational statement uses the verb will. Note that operational statements are frequently called user stories. Asking the customer to create user stories is a very effective method for creating requirements, especially with systems that have a high level of user interface, such as apps or websites. However, these are not requirements. Another mistake I see in requirements is including unnecessary design restrictions. I like to give my system architects and designers maximum flexibility to design the system as effectively as possible. Unless there is a specific need for a design restriction, leave them out and allow your designers to come up with the best approach for developing the product.
Another issue regarding requirements is the issue of constraints. Requirements and constraints are different, so I keep them separate. Requirements are adjustable. Both product and project requirements change, but constraints don't. I actually call them non-negotiables. Let's take a project deadline as an example. While many project managers think the project deadline is a constraint, it can change. If the customer decides they want to add more functionality to their products, you'll need more time to develop that new functionality. Project deadlines change all the time. In contrast, constraints cannot change. Here's an example. I once had to develop a project methodology for installing MRIs and CTs in hospitals and clinics. In order to install such equipment, the installers need to drill into concrete. Drilling into concrete creates vibration, noise, and dust. Certainly, you wouldn't want this to happen while the surgeons are performing surgery. So, each of the methodologies included a constraint that no installers could drill into concrete during operating room hours. This constraint was never to be violated. I strongly recommend separating your requirements from your non-negotiable constraints.
Now let's look at some poorly written requirements and see how we might improve them. The first is a common example of a poorly written requirement. It is not specific, not measurable, and not easily testable. Well, how might you improve this requirement? This one will take a few additional requirements to fix. First, I might specify the number of mouse clicks required to navigate the web pages. I might also focus on readability, defining the size and type of font used. Certainly, a few more requirements would be needed to achieve user-friendly, but I think you get the idea. Our next one is a bit easier to fix. The requirement, as written, is not specific nor testable. To fix this, we simply put size restrictions on how much space our transmitter module will take on the chip. Our next one is one of my favorite examples of a bad requirement. I actually had to address this one while working on air traffic control systems. It was requirement number 2 in our list of over 250 requirements. The acronym NAS stands for the National Airspace System, a computer system that interfaces with radars, air traffic controllers, and pilots to keep airplanes from bumping into each other at 30,000 feet. While doing our scope review for our client, the FAA, I asked what the philosophy of the NAS was. Well, they couldn't tell me. So I said, "You know I have to prove that I've met this requirement. Tell me how to prove it." Their response, "I don't know." "Okay," I said. "Well, at this point we have 3 options. 1, you can tell me what the philosophy of the NAS is, and I'll gladly build a system that meets it. 2, we can pull the requirements since it doesn't seem to be very important. And 3, we can go on time and materials contract, but I cannot give you a firm fixed price since I'm not sure exactly what I'm building." Well, they decided to pull the requirement. Our last example is another common one. The system shall have a fast response time under full load. We see that it is not measurable. To fix this, we simply make it measurable. Of course, we would have to define what full load is.
I hope you found this micro lesson informative and enjoyable. We look forward to seeing you in the next micro lesson.